Hello, class. In this lesson, we will discuss the catalytic cracking fractionation process. A catalytic cracking fractionation tower is a type of chemical equipment used for fractionating mixed volatile liquids and is an important unit in the secondary processing of petroleum. Its upstream process is the catalytic cracking reaction regeneration system, and its downstream process is the catalytic cracking absorption stabilization system. The basic principle of the catalytic cracking fractionation tower is separation based on the difference in the relative volatility of components in the gas and liquid phases. In the tower, vapor rises from the bottom to the top, while liquid flows down from the top to the bottom. On each tray, when the gas and liquid phases come into contact, partial condensation occurs in the gas phase, and partial vaporization occurs in the liquid phase. Due to the partial vaporization of the liquid, light components in the liquid phase diffuse into the gas phase, increasing the concentration of light components in the vapor. Meanwhile, the partial condensation of the vapor causes heavy components in the vapor to diffuse into the liquid phase, increasing the concentration of heavy components in the liquid. This process brings the interacting gas and liquid phases on the same tray closer to equilibrium. Both the atmospheric tower and the fractionation tower operate on the principle of distillation. What are the characteristics of the atmospheric tower we previously discussed? From the perspective of distillation, it has a rectifying section, and the number of trays is relatively large. From the perspective of the stripping section, it does not have a stripping section. From the perspective of the vaporization rate, the feed composition has already undergone partial vaporization and is not a cold feed. From the perspective of product composition, the atmospheric tower produces multiple products, among other characteristics. From this, it can be seen that the fractionation tower and the atmospheric tower share many similarities. For example, both have high-temperature feeds, no reboilers, only a rectifying section without stripping section. Both require maintaining a certain overflash ratio, and the types of products are largely the same. However, the fractionation tower also has differences from the atmospheric tower. First, the feed to the fractionation system is superheated oil gas carrying catalyst dust. The bottom of the fractionation tower is equipped with a desuperheating section. Second, the bottom of the fractionation tower is equipped with herringbone baffle, using cooled slurry to cool the oil gas to a saturated state and wash off entrained dust to facilitate fractionation and prevent tray clogging. The fractionation tower has slurry circulation. The purpose of the slurry circulation returning to the tower is desuperheating and washing the catalyst, preventing the oil gas from carrying catalyst to the upper sections and clogging the trays. This aligns with one of the principles of reaction operation. Catalyst circulation must be maintained alongside slurry circulation. Why? Because during catalyst circulation, it is inevitable that a small amount of catalyst will carry over into the fractionation tower. If slurry circulation is not maintained, the solid content in the slurry at the bottom of the fractionation tower will not only increase, but the catalyst entering the fractionation tower will also migrate upward, clogging the trays. Therefore, slurry circulation must be maintained during catalyst circulation. To remove excess heat from the fractionation tower, it is equipped with top circulating reflux, 1 or 2 intermediate refluxes, and bottom slurry circulating reflux. Generally, the upper part of the fractionation tower is reduced in diameter. As we know, the temperature decreases toward the top of the fractionation tower, and the gas flow velocity also decreases. Reducing the diameter of the upper section ensures gas flow velocity and maintains fractionation equilibrium. Top reflux uses circulating reflux instead of cold reflux to save cooling capacity in air coolers. In the fractionation tower, the reaction oil gas is separated into several products. Overhead products, gasoline and rich gas, side streams, light diesel and heavy diesel. Bottom products, slurry and recycle oil. Here, we mention light diesel and heavy diesel. To expand slightly, light diesel is primarily used as fuel for diesel locomotives, tractors, and various high-speed diesel engines. Heavy diesel is mainly used as fuel for ships, power generation, and other diesel engines. The products obtained from the catalytic cracking fractionation tower differ in composition from those obtained from crude oil distillation. The catalytic cracking process produces unsaturated hydrocarbons. Therefore, hydrocarbons of C4 and below produced in this process need to be sent to gas separation units for separation. Other crude oil processing methods, such as atmospheric distillation, hydrotreating, hydrocracking, and catalytic reforming, produce gases containing only saturated hydrocarbons, which are separated in saturated hydrocarbon separation units. Aromatic hydrocarbons in catalytic cracking products tend to concentrate, and the proportion of benzene rings in the molecular structure tends to increase, which is beneficial for improving the octane number of gasoline. China's refining industry has made tremendous progress from scratch. Thanks to the relentless efforts of generations of pioneers in the refining industry, academician Qin Zhenwu, the founder of China's refining catalytic cracking engineering technology, dedicated his life to the refining industry and committed himself to the service of the nation. When a reporter once asked the 93-year-old academician Chen if he often read newspapers, he earnestly replied that he did, noting that compared to developed countries, China's refining technology still lags behind, and continuous learning is necessary to keep up with the times. We must learn from the deep patriotic sentiment and unwavering dedication to scientific research embodied by the older generation of scientists. All right, class, that concludes this lesson. See you in the next class.